Alright, so this is an 180-degree turn stair. So this will apply to 90-degree turn stairs, and then little bits will apply to straight flight stairs with a landing, but I can go into that later. So there's going to be a couple different things that you see. If you watch my previous video, you know that I'm just kind of doing this stuff over to help any of the apprentice carpenters out there that are struggling with stair math, just as I did. So, a couple of the different things, you're going to have height above landing. So the abbreviation is HAL. So height above landing is this measurement here. It's going to be from this landing here to this upper landing right here. That is height above landing right there. So with 90-degree turn stairs and 180-degree turn stairs, you're going to have to take into account landing length, but I'll show you how that applies later. Your calculated opening length is also going to be slightly different. It's going to be calculated different, I should say. So you can see your calculated opening length goes from this edge of this slab right here to this edge, basically where the stair fits in, or the stairwell. So the other main difference is the lengths are portrayed a bit differently. So this is called length AB and BC. So you can see from the edge of this slab here, there's a plumb line all the way down here. So from the corner of this nosing, A, this shoots out, and where it intersects, that's going to be length AB. And then if you carry that plumb line all the way down to the stairs, that is going to be length BC. And then the headroom is still the same. So I mean, if you're struggling, feel free to watch my other video. But so first things first, this is going to be a public stair. So take that into account, because at least for my situation, when the public and private rise and runs and headroom are going to be different, and then that can really mess you up if you aren't given like a rise, or it's just given minimum or maximum rise, or headroom or whatever. But I go over that a bit more in my other video. So same process here. You're going to go total rise. For your number of risers, you're going to go total rise divided by desired rise. So that would give you 3,600 divided by 170, because this is the desired rise. And then I got 21.17. So you can have 21.17 risers. So I just rounded that down to 21. But if I had 21.56, then I would round that up to 22. So unit rise is going to be total rise divided by the riser number that you just got. So it'll be 36 divided by 21, and that's going to give me 171.43. So that is going to be the unit rise, or the riser width on this stair. So the unit line length, again, is that triangle that you're trying to find for the rise and run intersection, right? So you're going to go run squared plus rise squared. So that'll give me 171.43 squared plus 280 squared. And then I'll do that on the calculator, just so you can see the operation of it. So 280 squared plus 171.43 squared equals, and then second function and shift. So I got 328.31. So 328.31. So this is where things get a little bit different, or a little bit tricky. So when you're asked for the number of treads above the flight, Sometimes they'll try and trip you up and say the amount of risers or the amount of treads. Pay attention to this word, right? Or they'll flip it. They'll be like, oh, this question here, I want the number of treads, and then this question here, I want the number of risers. So just make sure you read really carefully. So for this, basically when they tell you this location, the landing location, like 5 risers down, they're looking at the stair from almost like a bird's eye view, or like they're standing on the very top of the landing, like the very top of the stair and looking down. So that is indicated by down. You do the opposite if it said up. So looking at it down from the very top of the stair, this landing location is going to be 5 risers down. So the way that you do this, since this is number of treads, keep that in mind. You're going to go 5, and then you're going to minus 1, because there's always one less tread than riser, and then that'll give you 4. So for your lower flight, you're going to work opposite. So you're going to go 21, your number of risers, minus 5 for that position in the stair, and then you're going to get 16, and then that'll give you the number of risers, because it's basically the opposite of this number here. And then you're going to minus 1, since it just gave you the riser number, and then you're going to get 15. A good way to do it is with the stair with landing, there's going to be 2 less treads than just a straight flight stair. So if you add these up, so 15 and 4, that'll equal 19. That is 2 less than 21. So you know that you did it right. So the total run for the lower flight, it's almost the same process. So you're going to go 15 times 280, because 280 is our unit run. And then you're going to get 4,200. So that'll give you the total run of the lower flight of stairs. So height above landing, this always got me, because I would do weird things like minus 1, but height above landing is relation to rise, not to run. So just keep that in mind. So essentially, your landing location, 5 risers down, you're just going to go 5, because in this case it's 5 risers down, and then times your rise, which is 857.15. And yeah, that's all there is to it. So for length BC, this one is pretty critical. Same with height above landing. If you get any of these wrong, it'll screw up the equation. Especially height above landing. If you don't do this right, it'll screw up the entire equation. So for your length BC, you're going to go drop to line of flight, which is required headroom plus your upper floor thickness. In this case, it's 2225. And then you're going to minus your height above landing, which is 857.15, and then that'll give you this number, which is 1367.85. Okay, so you're done length BC. So now you have to move on to length AB, and that is going to be run divided by rise times length BC. So it's going to be 280 divided by 171.43 times 1367.85, and that is going to give me 2234. Okay. Now with this number, for your calculated opening length, remember how I was saying that calculated opening length is calculated differently with a 180-degree turn stair? So you're going to take your length AB, and then you're going to add the landing length to it. So length AB plus your landing length, and then plus 1 nosing, which in this case it is 25. And then that number should be 3259.15. That'll be your calculated opening length. And there you go. That wasn't too much harder, was it? So I can quickly show you 90 degree turn stairs. So it's very similar. It's almost the exact same, really. You know, a 90 degree turn stair compared to a 180 degree turn stair. The only thing that's really different about a 90 degree turn stair is you don't have to add your nosing on the calculated opening length. But the process is the same. Like height above landing is the same. Length BC is the same. It's just drop to line of flight minus your height above landing. So yeah, like if you can do 90 degree turn stairs, you can do 180 degree turn stairs. So I just thought I would help somebody out, because I really struggled